Greetings everyone. So now we are going to discuss about the thermodynamic principle. So it's just important to understand that how thermodynamic principle works. Let's suppose if we are having a system, if we have a system in which the temperature is given as Ts, and in the environment the temperature is given as Te. Now the temperature in system, let's suppose, is greater. Temperature in system Ts is greater than temperature in environment. So as temperature in system is greater than temperature of environment, what actually will happen, temperature will start, the amount of energy which is present in system will start to move into the environment. The energy from the system will start to move from the environment. That energy which moves in the form of something is known as the heat. It's important to understand that what sort of energy is this. So if we talk about the total energy of a body, total energy of a system, total energy of a body refers to the total kinetic energy, and potential energy of a body, total kinetic and potential energy of all the molecules which are moving randomly, of all molecules. So total kinetic and potential energy of all molecules is known as the internal energy, and that internal energy changes, which causes to create a change in temperature. So what temperature is simply the measure of the difference in the internal energy. Temperature is not the absolute measure of internal energy, because internal energy is not be measured in its absolute values. Internal energy can only be measured in terms of its difference. So internal energy being measured in the terms of difference can only occur if we are taking the temperature. So what temperature is? Temperature is simply the difference in the internal energy of the body. If let's suppose if we are saying the temperature, the system Ts is having the temperature higher. So Ts having a temperature higher is because its internal energy is higher. So if it possesses higher internal energy, then it is Ts. So its temperature is also higher. While T is having lower internal energy, due to which due to which its temperature is also higher. Temperature is also lower. Now, since internal energy of Ts is greater than internal energy of system is greater than internal energy of environment, the transfer of internal energy occurs in the form of something, because if internal energy needs to be transferred, we cannot transfer it simply in the form of kinetic energy or simply in the form of potential energy, although there are other means of doing so as well. But one of the means of transferring internal energy from one body to another body is heat energy. So heat is basically the mode of transfer of energy, and that mode of transfer of energy occurs in the form of heat, and that requires a difference in internal energy. So the first thermodynamic principle says that if two bodies are having a difference in their temperature, a difference in their internal energy, then they must equalize their internal energy. They must equalize their temperature. So what does this mean? This means that the temperature of system should be equal to temperature of environment. And for that to occur, we need the transfer of internal energy from its higher state to lower state, and that occurs in the form of heat. So heat in actual is not an intrinsic property. Heat is not an intrinsic property. Energy is an intrinsic property. Heat is just a mode of transfer of energy in the form of heat, right? And it occurs due to temperature difference, or the only means that helps heat to be transferred is temperature difference. It is the first condition for um, transfer of heat through internal energy. Transfer of heat, and if we take example, the opposite example, if temperature of environment is greater than temperature of system, then if let's suppose if you are taking a cup of cold drink in which there are several ice cubes, right? And several ice cubes are there in the cup of coffee. and temperature of environment is greater than temperature of system, or the internal energy of environment is greater than internal energy of system. So in that regard, the heat will tend to move from the environment into the cup, or from the environment into the system. As it will tend to move from the environment into the system, it will start to, you know, equalize the environment energy of the temperature to that of system. So until the temperature of the environment does not becomes equal to the temperature of the system, the transfer of energy will occur in the form of heat. So this is a condition which occurs over here, that for the thermodynamic principle, in order to equalize the temperature difference, so for that temperature difference, we need everybody needs to have the temperature difference. System needs to have temperature difference equal to its environment. So this is an important part of it. All right. So this is an important part of it, that internal energy. That's an important part of it, that internal energy of both bodies of system as well as environment, temperature of of the environment and the system should be equalized or in equilibrium. And if it is not in equilibrium, then energy will be transferred from in the form of heat from the hotter body, or the body having high temperature, to the body having lower temperature. Or and from this we can also say that temperature does not helps us to measure how hot or cold the body is. It tells us the direction in which the heat travels from one body to another body. That's a major function of temperature, rather than the temperature doesn't say that how much hot or cold the body is. Even coldness doesn't exist. Coldness is not a quantity at all. It's just absence of um, heat. And heat itself isn't just anything, because heat is simply the mode of transfer of energy in the form of heat. So temperature is what shows us that uh, there's if there's a difference, if in temperature, then it will show us the direction of heat, that from which body to which body the heat would be transferred. And that, since temperature tells us the direction of transfer of heat. This is all about the video. Hopefully we'll meet in another video.